thing here. This is a completely it's a completely improvised live stream. I'm just going to check, make sure it's all working. Make sure it's all working on my computers here before I begin. But today is a very special stream because what I'm going to be doing is beginning to build some of my instruments that I want to use on my album and my shows coming up. I've got so many ideas lately. I've just had so many ideas. There we go, that's working there. Let's go check one more channel. Oh, where's it gone? It's all down. There it is, got it. And let's check that one too. Basically, what I'm going to do today is ask Chat-GPT to help me build something that I'm going to use. What I wanted to do is create some generative landscapes with my new modular synths. I can show you them. So these gadgets here, I'm going to be building something to what's the word? To create like generative, fading, ever-evolving ambient landscapes of sound. The track you're hearing there is just something I improvised a couple of weeks ago. So let's bring up Chat-GPT. I'm going to try this. I want it to help me design a simple surge style up-down modular synth Eurorack module like you get in noise maths. If you don't know what this means, don't worry about it. It basically is just modules that I would like to build, and this is the stuff I've got. So let's see what it comes up with and see if I can get it to get Chat-GPT to design something.
There was something about flying in my dream, 'cause flying is what I attempted to do. I attempted to do. I attempted in all my days of wonder. I attempted
Wow, I've literally got a book here.
Attempted to
Okay, let's read
deny
that out loud.
the unimpossible.
All right, BexX, this is a lovely place to start. You've basically got the bones of a surge-style slope generator already. What you're building is essentially a single-channel function generator. Rise, peak, full. Voltage controlled if we design it cleanly. I'll keep this simple and solid so it actually works first time. No feature creep. Overview, what we're building. A single slope generator with manual full decay, CV input, 0.8 volt style output, surge maths-inspired behaviour. This will behave like an AD envelope if triggered, a slew limiter if fed CV, an LFO if looped optional future add-on. For now, one stable slope generator, core architecture. The TL072 gives you 2 op amps. Use them like this. Op-amp A integrator, the actual rising falling ramp. Op-amp B, output buffer. The diodes create separate charge and discharge paths, so rise and fall can be different speeds. That's the surge trick. Stage 1 power wiring. Do this first. TL0S2 pine out, 1 out, A2 inverting, A3 non-inverting, A4 minus 12 volts, 5 non-inverting, B6 inverting, B7 out, 8 plus 12 volts wire, pin 8 plus 12 volts, pin 4 9 to 12 volts, 100 NF of ceramic cap between plus 12 and minus 12,
Seriously,
as
what is
close
she
to chip as
saying?
possible. Important, also add 100 NF from plus 12 to ground and minus 12 to ground if you can. If you don't, it may oscillate. Stage 2, the integrator core. This is the heart. Use op-amp A as an integrator. Pin 3 non-inverting ground, pin 2 inverting timing node, 10 MHz capacitor from pin 1 output to pin 2. That capacitor is your ramp generator. Now we control how fast it charges and discharges. Stage 3, rise fall network. You'll build 2 paths feeding into pin 2. Rise path, CV in 1N4148, anode at CV, cathode toward pot. 1M rise pot, pin 2 fall path, pin 1 output. 1N4148, anode at pot side, cathode at output. 1M fall pot, pin 2. The diodes force current to flow differently depending on voltage direction, giving separate charge-discharge times. The second 10 MHz cap you listed
babe,
is
this
not
nuts.
needed in the integrator core. Use it optionally for shaping or trigger conditioning later. Stage 4, discharge resistors. Add 1M resistor from pin 2 to ground, 1M resistor from CV in to ground. These prevent floating behavior and stop weird latch states. Stage 5, output buffer. Use op-amp B as a buffer. Pin 5, pin 1, output of integrator. Pin 6, pin 7. Pin 7, CV out
Right,
jack.
let's stop her there.
That gives you a low impedance output that won't distort when patched. What you now have feeds CV into the input. Slow pot equals long rise, slow decay pot equals long fall, fast pots equals snappy transient. If you feed a
Right, babe, you need to, she's speaking a foreign language to me. I need her to give me the steps, step by step. All right, so let's try this then. Step 1. No, I mean like step one step at a time. One step at a time until I've completed that step. Let's start at the beginning. Right, what did she say? Let's read that out loud.
Yes, good. We're doing this properly. One step. You do it. You tell me when it's done. No overwhelm. No. Step 1. Insert the TL072 into the socket. Take your 8-pin socket, find the small notch on one end of the socket. Now take the TL072 chip. Find the little half-moon notch on the chip with the notch on the socket. Gently push the chip into the socket until it's fully seated and straight. Do not bend legs. Do not power any.
Okay, well that's quite easy to do. Let's do that. Let's start at the beginning. Sometimes she just rabbits away, doesn't she, really? Like, just rabbits away with loads of information that you don't really need. So yeah, right. Here is the chip that she's talking about. So this is basically going to power my synthesizer. My synthesizer, what do we call this now? It's like, it basically goes up and down. Like, it's an up-down. So I'm going to stick my chip in there. And then Charlie's going to help me carry on building it. So if I do it that way, maybe I need to do it the other way around because that's up and that's down. Oh, it's already bent the legs. Like she told me not to. She told me not to do that. So basically, if you just tuned in, I'm seeing if Chat-GPT can help me build experimental synthesizers. I've been wanting to, like, get a particular sound, and I've been wanting to, you know, create a new show. Well, and for my album actually. So my whole project this year is to finish my album, which has been funded by Help Musicians, and this is all part of that. Basically, I've got got to develop this new sound. So great that you're here to share that with me, and I can share that with you. So, done that. Let's see what she says next.
To try again is a blessing. To try again.
Right, so what she's saying is,
To try again is a blessing. Is a blessing.
don't draw it for. I think she'll get it wrong or something like that if she draws it. LJ Whelan, I don't know what you mean. Sorry. Do you want to elaborate on that? I'm not sure. Right, so then let's go back to this. Okay, wiring power, pin 8 and pin 4. Oh yeah, no, that's fine. Okay, that's it. Let's do that. Pin 8 and pin 4. Right, so let's get some wires. And we're going to go from pin 8 up to the top here. Pin 8 is what? That one there. 1, 2, 3, 4. So I just need a little thing. About that long. Yeah, that'll do. Let's get the music up. While I build this thing. What did she say again? Okay, yeah, let's do this one.
try again. Is a blessing. Or maybe a curse, depending on how you look at it. Depends on your perspective. Depends on your point of view. Try again. There's a blessing, or maybe it's a curse, depending on your
even better. I like action. Step 4. Add the timing capacitor. This makes the ramp. Take one of your 10 FF electrolytic capacitors. Important. Long leg equals positive, stripe side equals negative. Connect. Positive leg, pin 1, negative leg, pin 2. Double check orientation before soldering. Do not connect anything else yet. Tell me when that capacitor is in.
Right, no idea what this is. So let's do some hunt. Let's play hunt for the capacitor.
Try again. Try again. try again. It's not so hard.
Take 1
Try
mega.
again.
1 mega.
Try again.
Is it the variable? No. It's just a normal. Right, one end, pin 2, the other end to ground. Pin 2, the other end to ground. That's what she said.
Try again.
Pin 2,
Try again.
what did she say?
Try again. Try again. Try again.
I should
I
definitely
thought
do
it
what
was
they said.
over.
Long leg.
I thought it was over.
Right, so the minus goes to pin 2. That's it. Got it. And then step 5, add the stabilizer resistor.
I thought it was over. But it's not so hard now. It's not so hard.
Take 1 meg resistor.
This is
Right,
a
one end to
blessing.
pin 2, the other end, one end to pin 2, other end, ground.
It is a blessing.
2. Okay, that's good.
Try again.
Done. Right, 6. Prepare your CV input path. Tip, signal, sleeve, ground. So the tip needs to be let's read that out loud.
Nice, we're cruising. Step 6, prepare the CV input path. Find your CV in jack. On the jack, typical signal, sleeve equals ground. Do this next. Connect CV in jack, sleeve, ground. That's mandatory for noise stability. Then take 1N4148 diode. Look at the diode, one side has a black stripe. Connect CV in jack tip, diode, non-stripe side. Diode stripe side, 1M rise potentiometer outer leg. Choose one outer leg. Do not wire the pop middle leg yet. Tell me when this is done.
It's not so easy to give up. It's not so expected of you to carry on,
Oh, I don't know where it is.
but it's okay
Where's the other one?
to try again. Just stand up and breathe in the air. Just stand up and inhale the air into your lungs. Stand up and try again. Try again.
Right, let's read that again.
Nice, we're cruising. Step 6, prepare the CV input path. Find your CV in jack. On the jack, typical signal, sleeve equals ground. Do this next. Connect CV in jack, sleeve, ground. That's mandatory for noise stability. Then take one 1N4148 diode. Look at the diode, one side has a black stripe. Connect CV in jack tip diode non-striped side. Diode striped side, 1M rise potentiometer outer leg. Choose one outer leg. Do not wire the pot middle leg yet. Tell me when this is done.
1M rise potentiometer urgently. Okay, cool. So can I find those things? Lost it again. Where is it? Where could it be? Lost it again. Literally, I don't know where everything is. Right, I had them not so long ago. Where the hell have they gone? Don't know where it's gone. Okay, let's try something else. Nice one. What should we play next? Let's get some more music on. Hey Maya, how you doing? Let's get a little bit of right, what should we play next? Bit of that. Basically, if you just logged in, if you've just tuned in, then I'm building a synthesizer to add to my album, to play on my album and to play my live shows with. This next track's one I made a couple of months ago now. It's called Power and Connection. Let's get the sound up a bit. Am I from the States? No, I'm not from the States. Where are you from? Do I sound American? Maybe I do, I don't know. I don't know. It is. This is breadboard, so I'm building a little device to add to my synthesizers to basically make some live music with. And I want to make it today, if I can. But obviously, these things, they do take a bit of time to test and make sure they work. So, let's get this going. I need to solder that on probably. So I've got a whole line of instruments and gadgets that I want to make. And then I can have people interacting with them. I think that's that one. And let's try this now. Right, so what did she say again? Let's have a look. What's she saying?
Nice, we're cruising. Step 6, prepare the CV input path. Find your CV in jack. On the jack, typical signal, sleeve equals ground. Do this next. Connect CV in jack sleeve ground. That's mandatory for noise stability. Then take 1N4148 diode. Look at the diode, one side has a black stripe. Connect CV in jack tip diode non-striped side. Diode striped side, 1M rise potentiometer outer leg. Choose one outer leg. Do not wire the pot middle leg yet. Tell me when this is done.
You know what, I'm going to put that there. Okay, there we go. So, the diode has a black stripe on there. Yeah, I see it. And then stripe side goes to 1M rise potentiometer outer leg. Okay. So I need that to go in. Yeah, so it's connecting. Right, that way, yeah. I got it. Oh, brilliant. Lovely. So what's a full adder? What is that? You just made an adder. What's an adder? What does that do? I'm literally just completely vibe engineering this. There we go. There's my one name box. So I'm making this really, I'm not going to be, I don't call myself an engineer. I'm not an engineer. I am an artist, and I like to, create interactive installations. And what I'm doing here is creating something that's going to be quite a generative, ambient soundtrack. A bit like what you're hearing, but different. A bit different to that. Yeah. Is the sound coming through all right? How does it sound? Right, how does this work? Gotta get that one there somehow. Let's try taking those back. Right, so we get that. And then there's the right, hopefully that's good. What do you think? Look good? Look good so far? Oops. Another one. Let's go read loud.
Brilliant, you're doing really well with this. Step 7, wire the rise potentiometer. Take your 1M rise pot. It has 3 legs. Let's call them left, middle, right. Doesn't matter which side you hold it. Do this. Middle leg, pin 2. The outer leg that is already connected to the diode stays as it is. Now take the other outer leg of the rise pot and connect it to ground. That completes the rise path. Tell me when that's soldered.
Good. Okay, so that one has got to go to pin 2. let's get this off. Okay. Middle one, pin 2. How long does that go? So maybe like that. Right, middle leg. That. Pin 2. Oh no, that's not pin 2. I keep getting these mixed up. That's pin 2. Right, yeah. Alright, let's try that. That was to stay in there. Doesn't really stay in there, does it? That's no good. And then, what's next? What does she say is next? Oh yeah, pin 1. The outer leg connected to ground. Right, okay, that's the next thing to do. Connect the next one to ground, which is there. Is that a logic circuit? I don't know. I'm not, like, too familiar. Basically, I just want to create art. It's all about expression. Right, what's next? What is next? Okay, done. Right, this is so much better doing it like bit by bit. At the beginning, she was
Nice
just like
work. Seriously, this is coming together.
chatting away.
Step 8, add the full path. Take your second 1N4148 diode. Look at the black stripe. Connect pin 1 non-striped side of this diode, striped side of diode, one outer leg of the full pot 1M. Now, take the full pot middle leg and connect it to pin 2. Finally, connect the other outer leg of the full pot ground. Tell me when the full path is wired.
Okay, gotta get another 1M. 1M, where's the 1M gone? That is the 1M. That one, yes, that's it. I need a quick way to turn on and off the screen, don't I? Need like a foot pedal. That'd be good. I wonder if it can connect to MIDI this. Right, let's get this cleared. I don't know if that's even working on that one. Let's see. What's the weather like where you are? Beautiful here. Shame I'm not doing this outside, really. Okay, that's it. Right, the pin 1, non-striped side of this diode is to pin 1. No, it's the other one. Oh, I keep getting it wrong. One outer leg of the 4-pot. And then connect the middle one to pin 2. Let's skip a bit of this track. Let's go for this one.
I twist in conflict and overthinking. Withdraw to avoid being hurt.
Okay, that's that. Good. What is that? Feeding in.
Trying to outthink pain. Trying to outthink pain instead of feeling.
I'm gonna end that one.
Instead of feeling.
I don't know why the rest of it's struggling a bit. Alright, cool. Right, next bit. Right, what's the next bit? Maybe that'll help. Right, what's she say now? So let's go to the, right, so I've got the second diode going there. Look at the black stripe. Connect pin 1 to the non-stripe side of the diode. Pin 1. Yeah, that's done.
Oh, of course.
Is that 8? Yeah, that's right.
God damn it.
That's minus. Good. Right,
Fuck's sake.
non-striped side of the diode. So that goes in there like that. And now what? Then the middle one. Connected to pin 2. That's done. Right, all done now. Oh wow, is that all that is? output buffer wire and use the second half of the TL072, pin 5 to pin 1. Connect these exactly. Pin 5 goes to pin 1. Pin 5, 1, 2, 3, 4, 5. Pin 5 goes to pin 1, just like that. Just like that. Pin 5 goes to pin 1, just like that. One's there. 1, 2, 3, 4, 5. There we go. Okay. And pin 6 to pin 7.
I twist in
I kind of need to
conflict.
draw this out actually. I'll do that at the end. I can double check everything.
I twist in
So pin 6
conflict
went to
and
pin 7, so this is just a little
overthinking.
very small one.
Withdraw
1,
to
5, 4, 5, 6,
avoid
7. Yeah, these two.
to avoid being hurt.
7.
Trying to outthink pain.
That's it, that's good. And then
Instead
now
of
wire 7 to
feeling
CV out. So I need to get the hang on.
when it feels hollow from survival.
Right, so then let's just finish this off and then I'll get to that. So pin 7 to CV out, jack sleeve to ground. Oh yeah, gotta do one of those. One more of those. Little gadgets.
While I recreate the energy
And then let's see what happens.
of multiple caused endings. Stop trying to escape the inner battlefield. That's where the real reward lies. Not to fight to the death, but to make it easier. Come to terms in acceptance of the whole parts of me. I shut down that.
So I asked her, what does the CV input do? I thought it would only need an output. So let's check that.
It is necessary.
Good question. You're thinking like a circuit designer now.
Thanks,
The CV in lets something outside control the slope behaviour. Without CV input, you would only have a manual envelope generator. With CV input, you can do things like trigger the envelope from a gate signal, control rise-fall speed dynamically, use another oscillator or LFO to modulate the slope. If you removed CV in, the module would still work, but it would be far less expressive and would feel more like a fixed envelope, so it's optional in use, but important for modular flexibility. Right now, you're wired correctly. Next step is very important and slightly scary, but simple. Step 10, first power test. Before plugging into your Eurorack bus, 1. Check visually. No wires touching plus 12 volt and minus 12 volts together. Electrolytic capacitor polarity is correct. Diodes face correct direction. 2. Set both pots to mid position. 3. Plug module into power. 4. Watch and feel for smoke, burning smell, chip getting hot within 5 seconds. If anything happens, unplug immediately. Tell me when you're ready to power test. I'll stay with you for this part.
Okay, great.
To go deeper and discover a new way.
Okay, so now we're going to try plugging it in. Let's get this ready.
Reality, it is my labor,
Let's see if this works.
and it really is all
Yeah.
in the mind.
It's not working. That's not right. Huh. That's odd. That's off.
My core frequency. My core frequency is true.
Drain.
My core frequency.
Alright, so gonna have to sort out some power somehow.
My core frequency is true.
So that's for all for today. So if you've just tuned in, then what I've done in the last hour is built a little gadget that rises and falls
Cut through the
level going into my synthesizer. So I'm going to be making some ambient generative soundtracks with this. I'll be live streaming that maybe later if I can. But I've got to get the power sorted now, so I'm going to have to come offline. Maybe I'll play a bit of this track first. This track is called Power and Connection. While I get the connection right for the power on this little gadget, then I'll play a bit of this. Let's go.
That's what I'm calling it. chord.